Hello everyone. I'd like to review what we're going to be covering this week in Module 3, and I'm going to pay particular attention to the two slides, and I'm going to provide some detail about that. And I'm also going to pull up the assignment for this week and kind of give a heads up about that. So let's first go to the Chapter 2 slides. And let's see here. Here we go. And it covers the basic measures of central tendency and variability. And I'm not going to spend a lot of time about how to compute the mean, median, and mode. I believe that everybody so far on the assignments has had no problems with this. Although when we come to the variance, I'm going to point out a slight difference that you may find in Excel and SPSS. Variability is the other descriptive statistic that is fundamental to everything that we're going to do in this course. But the mean and variance are part of calculations for statistical models and regression and analysis of variance. And so it's important to have a very good understanding about these two concepts. So for the mean, which is a measure of central tendency for interval and ratio data, that is going to be that point that is the best description of a typical score in that distribution. And I think it's important to put some qualitative information around these statistical concepts. So, because later on, when we're talking about z-scores, we're going to be talking about scores that are not typical of that distribution of scores. But the mean is, for all of our purposes, going to represent a typical score. And then the variability is a description of how scores deviate from the mean, or the spread of scores. And as you have read in your book and looked at the calculation for variability, standard deviation and variance, that is, the computational formulas are in respect to a deviation of each score from the mean. And basically, you know, if you just sum the deviations, and they would sum to 0, and so we square the deviations and then sum those squared deviations about the mean. So variability, standard deviation, variance are numeric representations of the amount of spread of scores about the mean. I'm not going to go through the formulas for computing the variance and standard deviation. I will say that if you're going to use Excel, which is perfectly okay for some of these exercises, there are two types of formulas for standard deviation and variance. One of them assumes the population that these data represent. But in this course, unless otherwise stated, we will assume that any scores that are presented to us represent a random sample of scores from a population. So we're going to be using the formula that uses n-1 rather than n. n-1 is the way of addressing any kind of bias that is different between a sample and a population. Now, z-scores are a way to represent how far away a particular score is from the mean, but rather than using it in raw score measures, if we were dealing in airspeed, or mean weight or what have you, we would be able to compare different variables by standardizing those scores. So z-scores are a standardized representation of the degree to which a score deviates from the mean. And here is the formula for computing a z-score. It's the score minus the mean divided by the standard deviation. I do want to point out this normal curve here, and I think sometimes it is helpful, especially in the problems that you're assigned this week, to use a pencil and paper and draw out the normal curve, and that will help you visualize the problem. But here in a normal distribution, the mean, the median, and the mode are in the same position. And most of the scores between, let's say, -1 and +1 standard deviations, that represents about 68% of all of the scores. So in a normal distribution, the scores just seem to pile up like an anthill around the mean. Now, as these scores deviate from the mean, then the number of those scores represented in terms of a probability drop off quite quickly. So let's say that this normal representation was for the human height of males between 20 and 30 years old. That would be about 5 feet 10 inches. Well, somebody who was 6'5" would be probably somewhere about 3 standard deviations away from the mean. And that is just saying that it's very unlikely, very atypical to find someone who is 6'5". Most people are, between, say, 5'8" and 6 feet tall. So I want to kind of conclude here about what we're studying, the measures of central tendency, which are unique to different levels of measurement. The measures of variability, what we're mostly going to be focused on is the variance and standard deviation. Same thing, it's just that take the square root of the variance and that's the standard deviation. So it's ways of representing typical scores and the degree to which scores deviate from the mean, and then also computing them in a standard score format. So in the next slides on Chapter 4, I'm going to talk about the areas under the normal curve and then how that applies to samples and sampling and populations and so forth. So stay tuned.